We've got the top of the hour, so we're going to get started now. Good morning or afternoon, I guess. I'd like to thank everyone for taking time out of their busy day to attend today's presentation on the use of GeoWeb geocells in landfills. I'm your host, Corey Schneider, a business development manager with Presto Geosystems. I've been with Presto for 17 years and specialize in technical and site support, so I have significant experience in all of the products and applications we'll be discussing today. We are located in Wisconsin and manufacture erosion control, stormwater management, and porous pavement products that are used all over the US and the world. I have everyone muted now, so if you do have questions during the presentation, please type them into the question window and I will answer them at the end. Here are the things I hope you get out of today's presentation. We'll cover geocells in general, from development to applications, Presto's unique accessories that lead to stronger, faster installations, and then landfill-specific applications. Presto worked with the Army Corps of Engineers to develop geocell technology in the late 1970s and has been innovating ever since. We go beyond simply providing a product. You can find a lot of design and construction resources on our website, which is prestogeo.com. We do have experienced engineers on staff that can provide you with free project evaluations for any application where you are considering the use of GeoWeb. And then we will also provide contractor support to make sure that the product is not only getting put in correctly, but also as efficiently as possible. We operate in three general product areas: soil stabilization using our GeoWeb geocells, which can be used for load support, slope and channel protection, and building green retaining walls. We also have a line of porous pavements, of which we have both vegetated and aggregate solutions. And finally, lightweight reusable construction mats. We'll focus on GeoWeb solutions today. We'll now move on to discuss our soil stabilization capabilities using our GeoWeb cellular confinement system in general terms, and then as they relate to landfills. As I mentioned, Presto worked with the Army Corps of Engineers to develop geocell technology. While other materials such as cardboard and aluminum were tested, high-density polyethylene, or HDPE, was the chosen material due to its lightweight, flexible nature and the fact that it is inert to nearly all chemicals and climate conditions. What the Corps was looking to do was to make beach landings easier by confining that loose beach sand. And they were quite happy with the high-density polyethylene in the end. The GeoWeb system consists of two main attributes: cell size and cell depth. The cells come in three diameters: small, medium, and large, and cell heights of 3, 4, 6, 8, and 12 inches. Cell aperture and height are selected following an evaluation of project-specific needs and site conditions. To facilitate installation, we offer 5 different section lengths. The ultrasonically welded seam, where all of the connecting points are, is very important to the function of a geocell. The stronger the seam strength, the better the performance of the geocell. Strong seam allows for a heavier infill material, steeper and taller slopes, and better lifetime performance. GeoWeb is produced using high-quality virgin, high-density polyethylene resin for consistently strong welds at cell junctions, while also maintaining semi-rigid ductile properties within the cell walls, high stress crack resistance, and overall toughness and long-term durability in the environment. Our geocells do not use fillers or exotic polymer alloy blends, which can ultimately reduce weld strength and environmental stress crack resistance, and that are offered in some competing products in the name of increasing cell wall stiffness. To avoid weld failures and the damaging effects of differential settlement, uniformity in performance across all elements of a geocell system is much more important than stiffness alone. The table on the right is only a very general representation for summary purposes, but it gives you an idea of the cell size and cell depth combination that we use with each one of our application areas. Again, I want to reiterate that we do provide that free project evaluation services. And if you go through with that service, our engineers will recommend the lowest cost combination of cell size and cell depth that will still be suitable for your application. There are three main infill types for any GeoWeb application, depending on the type of protection needed: topsoil, aggregates and granular soils, and concrete. In most cases, geocells allow for the use of on-site materials without the need to import fill, generally with the only limiting factors being that the material should be angular and the maximum particle size should be about 1/3 the cell depth. Here we can see how the material ships. It's tri-folded, banded, and palletized. So it does ship quite compact, which can lead to relatively low freight costs. The material is lightweight, so no heavy equipment is needed for the installation. The nominal width for each section is 8.5 feet, but you can make them longer and skinnier or shorter and wider. But we do want to keep that width dimension to between about 7.5 and 9.3 feet. The length will depend on the amount of expansion and the number of strips welded together. But generally speaking, the length can vary between 12 and 58 feet long, with the 8.5 by 27 foot section that we're showing here being pretty typical, and that would give you about 230 square feet of coverage for each section. In order for a geocell system to perform uniformly, it is critical that both the factory welded junctions or internal junctions and field joined junctions that connect individual panels together perform at a level that is commensurate with that of the cell walls. The three primary elements of any geocell system, cell walls, internal junctions, and connectors, must perform uniformly as a complete system. Therefore, an incremental improvement in one characteristic, such as cell wall stiffness, is only valuable if a complementary improvement has been made in the other components of the system. GeoWeb is manufactured using a proprietary blend of high-quality virgin HDPE. Our formulation has stood the test of time for more than 40 years and contains no fillers, unstable polymer combinations, or alloys. For most typical sites, GeoWeb will retain its durability, with lab testing indicating 149 years before any degradation occurs, even at full exposure to the elements. We stand behind our specifications so you can deliver certainty in the solution as you build with materials you can trust. Made from high stability inert materials, GeoWeb geocells are your permanent stabilization solution and will not degrade, leach, or release microplastics into the environment. Our base resin is the same material used in environmental applications such as geomembranes and other environmental barriers to protect against the spread of harmful toxins, and our products have been third-party tested by accredited geosynthetics laboratories, confirming long-term stability against environmental factors such as weathering and oxidation. GeoWeb and all of our accessories are 100% made in the USA under strict quality assurance and environmental control processes, sure to comply with all requirements for Build America, Buy America, and the Infrastructure Investment and Jobs Act. Presto's GeoWeb is equipped with numerous design and construction components that increase strength and speed of installations. We have a variety of staking options, The standard method is to use our Atra stake clips on top of a 1/2 inch diameter or number 4 rebar. But if long-term corrosion is a concern, we can also provide high-density polyethylene speed stakes. Atra keys are the mechanical connection that I mentioned a few slides ago. Not only do keys provide the uniformity we discussed, but they are made of the same HDPE material as the GeoWeb itself, so they will last just as long. Beware of manufacturers that recommend staples or nylon cable ties, as these do not have the same long-term durability as HDPE. The tendon and Atra tendon clip system is ideal for anchoring the GeoWeb on slopes without the need for stakes, which would penetrate the liners that are used on most landfills. The tendons are tied to either earth anchors or a deadman pipe, which can typically be buried in the same trench as the liner at the crest. Now we'll go into a little bit more detail on each of the landfill relevant application areas, starting with load support. GeoWeb can be used for both surface stabilization of unpaved roads and base stabilization below pavements. Many solid waste facilities must contend with maintaining unpaved access roads. Not only can GeoWeb save money up front by allowing you to reduce your overall cross section, but incorporating GeoWeb into the roadway section can also help minimize or reduce annual costs associated with repair and maintenance of unpaved landfill roads that take a beating from heavy equipment and truck traffic. Generally speaking, the benefits of using GeoWeb in load support applications are that we can reduce your overall aggregate section by 70% or more. We control lateral and vertical infill movement, which prevents shearing, and we create a stiff base with a high flexural strength. Here's how the GeoWeb three-dimensional system works. When a vertical load is applied, the active earth pressure in the loaded cell pushes back against the passive earth pressure in the adjacent cell to form a stable system. Each cell helps support the ones around it. The GeoWeb cell walls also transfer hoop stress, which is important in keeping the system intact and creates a mattress effect. The strength of the seams around each cell, the material properties of the individual strips, and the connection method between panels are all important factors in determining how the GeoCell system can improve site conditions. Strong seams, semi-ductile resin properties, and integrated connections are critical to a well-performing system. The GeoWeb system and accessories are specifically designed to work together to be an effective solution for roads in soft soil locations. Here you can see the stresses on the subgrade with the unsupported subgrade on the left and the GeoWeb reinforcement on the right. Notice how there is a complete elimination of the highest stresses at the surface with GeoWeb reinforcement. The stresses are reduced and distributed over a wider area known as the mattress effect. This reduces stress reaching the subgrade and leads to a significant decrease in deflection and rutting. I want to quickly review a little of the research that we've done in the past to help increase your confidence in the use of GeoWeb. This first one is a static load test where we started out with a supersaturated peat mixture that was put under varying loading. Over the peat, the GeoWeb section was placed and infilled with aggregate. Settlement plates were placed throughout the GeoWeb section prior to its placement, and a load beam was placed over the GeoWeb and loaded to failure. This was then compared to the same depth of unconfined. The peat test showed that the bases reinforced with GeoWeb provide a significant improvement over unreinforced soils. So for a load of 1,000 pounds a foot, a 4-inch rut depth occurred in the GeoWeb section, whereas that rut was 20 inches in the unreinforced section. Since the previous testing was under static loadings, we also tested under a repeated dynamic load. Pavement load testing compared reinforced and unreinforced materials over the same subgrade. A deflection of 0.6 of an inch is assumed to lead to failure of the pavement system. Therefore, we applied the load repeatedly until that 0.6 of an inch of accumulated deformation occurred. Without the GeoWeb in the section, that took about 25,000 load cycles. By adding GeoWeb, we're all the way up to 400,000 load cycles, or an improvement of about 16 times the number of load cycles for the very same deformation. Notice the amazing strength of GeoWeb. It's strong enough to support a fully loaded dump truck that backs right up to the edge of the filled cells. This project is a good example of how GeoWeb can provide cost savings. Rather than importing expensive aggregate, the on-site silty sand material was used as the fill with only a 2-inch wearing course of aggregate required. We are also able to reduce the overall section from 36 inches down to 8 inches. We'll now look at a couple of quick videos showing how simple the installation is. Or maybe just one video. So here you can see that that truck can back up right to the very edge of where the cells are already filled. And they can simply empty out the bucket, and then they put a bulldozer or backhoe on it and spread the material that way. So it's a very quick and easy installation. Our typical section has a geotextile below the GeoWeb panels. That can be anything from a 6-ounce non-woven to an enhanced woven, depending on your subgrade strength and maximum loading. Then the GeoWeb is generally filled with aggregate, and we do recommend a 1 or 2 inch wearing surface over the panels themselves. Now we'll look at a few examples. Here, GeoWeb allowed a structurally sound road to be built with a clean stone infill. Without the GeoWeb, that stone would move with even one vehicle pass, but the clean stone and the GeoWeb perforations combine to allow this road through a wetland to be permitted, because water can flow through the section and not interrupt the hydrology of this wetland. Keep in mind, you get infiltration with clean stone infill only, and the permeability of the infill is going to be your limiting factor. Here, 8-inch GeoWeb and aggregate with a 40% void space was used. This allowed for 3 1/4 inches of rainwater to be stored in the pavement section, eliminating the need for additional stormwater infrastructure. You can also see the extremely heavy loads that are able to be handled by the GeoWeb system. Sometimes referred to as the cash registers for waste disposal, truck scales are important to just about every landfill and can also be supported using the GeoWeb cellular confinement system. The example shown is actually a railroad scale. However, the same principles apply for truck scales. By distributing loads laterally, GeoWeb will control settlement, making scales more accurate, reducing scale maintenance, and allowing for longer functional life. One of the biggest questions we get is about cost, which comes as no surprise. So the GeoWeb system costs compared with other stabilization techniques is very important. Here we have a basic comparison for a GeoWeb load support application, in this case, a gravel surface road. This comparison shows the difference in both price and cross-section depth for an aggregate only unreinforced section, the section using geogrids and geotextiles, and then 2 sections showing the use of the GeoWeb system, one with aggregate and one with salvaged on-site materials as the infill. In all cases, we assumed a subgrade CBR value of 0.5% and HS25 loading. You can see the GeoWeb system provides both thinner and less expensive cross sections, significantly so when on-site material is utilized. Assuming what's probably an outdated aggregate cost of $18 a ton, the unreinforced section is about $41 a square yard. The GeoGrid textile section around $40. GeoWeb with imported aggregate about $31. And if on-site material can be used, you're all the way down to $20 a square yard, which is less than half the cost of the unreinforced section. We'll now move on to discuss how GeoWeb can be used in stormwater conveyance, a critical component of any landfill design. Open channel designs with the GeoWeb three-dimensional system offer a more economical solution than riprap, gabions, or reinforced concrete, systems that are expensive and hard to place and maintain. The cellular network creates a system of check dams that protect the upper soil or aggregate layer from hydrological erosive forces that impact unconfined material. And the GeoWeb is going to be much more effective than two-dimensional solutions such as turf reinforcement mats or erosion control blankets that are subject to undermining. The benefits of using GeoWeb in channels are that it will improve the hydraulic performance of whatever infill material you use. And then additionally, with a vegetated infill, we promote infiltration and reduce runoff. With an aggregate infill, we allow the use of smaller, less expensive rock. And then with a concrete infill, there's no other form or reinforcement required. And it will flex with subgrade deformation and minimize cracking. Additionally, you can reduce your concrete thickness, leading to significant savings. Cell size, depth, and anchorage, as well as infill type, are determined based on channel geometry and hydraulic conditions. As mentioned earlier, free project evaluations are available on all projects, regardless of size. The cross-section like you see here, as well as calculations, are provided with every evaluation. Now we'll look at how GeoWeb works with the various infill options, starting with topsoil and vegetation. Generally speaking, low-flow channels like stormwater containment facilities and stormwater channels can be armored with topsoil-filled GeoWeb and covered with an erosion control blanket. But even in high-flow situations, we have a solution that can allow you to protect channels from erosion and maintain the aesthetics of vegetation. And this solution involves topsoil-filled cells covered with a turf reinforcement mat, or TRM. We tested the vegetated GeoWeb covered with a mid-grade turf reinforcement mat, not one of the newer high-performance TRMs, and received great results with peak velocities of nearly 30 feet per second and shear stresses of 16 pounds per foot. When we compare our results with some other standard practices, we see that we have more than twice the hydraulic resistance of 12-inch riprap and about double the performance of a high-performance TRM alone. And this combination system works because the TRM provides a cover so the GeoWeb does not scour out under high velocities. And the GeoWeb will confine the soil below the TRM so that the system won't fail when saturated. So in an unvegetated condition, GeoWeb will improve the hydraulic performance of a TRM alone by 50%. Typical applications for this system include roadside ditches, spillways, channel embankments, or dam and pond overflow systems, really suitable for any situation where you have high velocities but for relatively short durations. You can then maintain vegetation in areas that would previously have been concrete or very large riprap. We can also provide an aggregate filled solution. Generally, aggregate is used in arid regions where vegetation is difficult to establish or for areas that are typically underwater. And for the aggregate solution, we tested all 3 cell sizes and 2 different rock sizes, and then we ran a total of 90 tests. So with all those data points, Colorado State was able to run a regression analysis and provide us with this regression equation. So now, given the bed slope and the unit discharge of any channel, we can manipulate the median rock size and the cell size until we get to a point where our rock loss is 0. And when compared to traditional riprap sizing tools by Abson-Johnson and the Corps of Engineers, we can prove that we can reduce the rock size anywhere from 2 to 10 times, which can lead to significant savings, not only in your rock costs, but also transportation and installation costs as well. And finally, for your most challenging applications, concrete-filled GeoWeb. Poured in place with no additional forms or reinforcement, this allows for easier to place, higher slump concrete. And it is a flexible system that can withstand settlement very well, which is, of course, very important in landfill applications. We'll also assure uniform concrete depth, and typically a 3-inch concrete-filled GeoWeb can replace a 5 to 6-inch section of reinforced concrete. Once anchored in the channel, the GeoWeb allows for concrete to be either pumped or poured right into the cells. The concrete is then screeded and finished to the tops of the cells. And notice the flexibility of the concrete-filled GeoWeb panel is displayed on the right. It won't crack like poured in place concrete will. Again, the system was tested at Colorado State with very impressive results. The 3-inch deep cells filled with concrete were able to withstand 36 feet per second and 21 pounds of shear. And we didn't even fail the system at those velocities, but rather maxed out the flume. Now we'll look at a few examples. The regional municipality of Waterloo in Ontario, Canada, faced the challenge of creating an effective yet simple method of erosion prevention while removing stormwater from their newly capped cell at the Cambridge landfill. The protection system had to be durable and stable under a variety of hydraulic and mechanical stresses. Concrete-filled 4-inch deep GeoWeb panels were selected due to previous in-ground success with the system, the ability of concrete to limit vegetation growth in the bottom of the channel, and the overall flexibility of the system to conform to potential subgrade movement. A total of 15,000 square feet of GeoWeb was installed at the landfill, and the system was anchored with stakes in channels varying from 7 to 20 feet wide, with bed slopes up to 14.5%. The perforated GeoWeb system maximizes the mechanical bond between the concrete and cell walls, locking the concrete infill into the individual cells of the system. The concrete-filled system forms a uniform thickness mat which controls concrete quantities and cost. The system prevents uncontrolled cracking of the concrete and reduces the chances of piping or undermining. Next up is a project that we did at a landfill in Hong Kong. And you can see here we had a 460-foot drop from top to bottom with design flow rates of 350 cubic feet per second and maximum differential settlement expected to be 30 feet within the first 15 years. This diagram shows the location of the baffle blocks in cross-section and longitudinal section. The blocks were placed in the channel invert as well as on the side slopes, approximately every 8 feet downstream. Now we'll take a closer look at the installation. Here, the X's on the geotextile underlayment mark the location of the energy dissipator blocks. The GeoWeb was then placed and cut at block locations to make room for the energy dissipators. Next, the blocks weighing about 500 pounds each were placed. It's hard to see here, but the blocks are tapered from bottom to top. This way, when the concrete is poured into the cells, the blocks are locked into place. Finally, the concrete was poured with some of the slopes being in excess of 20%. Note the change in infill type with concrete on the bottom and up the sides, transitioning to a topsoil vegetation at the crest and on the back side of the berms. With the GeoWeb system, transitioning to different infills to handle various hydraulic conditions is quite easy. The channels drain not only the top of the landfill, but also drain across the landfill through flexible piping buried a few feet below grade. Finally, we move to slope protection. GeoWeb is a state-approved product for use in landfill capping applications. As of May 2020, GeoWeb was recently added to the North Carolina Department of Environmental Quality Guidelines for addressing pre-regulatory landfills as an approved technology for use in soil cover systems. As mentioned earlier, tendons and Atra tendon clips allow for anchorage without penetrating geomembranes. Tendons are either tied to buried deadman pipe or earth anchors, and the entire system is draped from the crest, with the clips serving to distribute the loading so as to not overstress any of the welds. The number and type of tendons, we have Kevlar, polyester, and polypropylene available, as well as clip spacing are provided as part of the evaluation process. Here we see an example of the tendon system over a liner. Again, no stakes are needed, allowing the integrity of a liner to remain intact. This is a pond at a golf course in Tennessee, and they didn't need to protect the entire slope as the water level varies only along the length of the GeoWeb panels. The GeoWeb serves to prevent soil erosion in the areas of the water level fluctuation. Here we have a borax mine in Southern California, again using tendons and tendon clips over a liner. GeoWeb is used for the access ramps into large containment ponds for cleanout operations. And it was placed at a 45-degree angle across and down the slope for access. In vegetated solutions, confinement prevents topsoil from washing out during rain events and or with fluctuating water levels. Here's another project, this one at a waste disposal site in Brazil. We have significant erosion after failure of the initial two-dimensional cover system. Here's the permanent solution, which consisted of a geomembrane covered by GeoWeb, which is anchored using the tendon system. Many times the deadman pipe can be placed in the same anchor trench as the liner for ease of construction. 1 year after the installation, we have a fully vegetated, erosion-resistant vegetated cap in place. The 68th Street Dump Superfund site, located in Rosedale, Baltimore County, Maryland, covers a substantial 239-acre area and comprises multiple landfills. These landfills were operational from the 1950s to the 1970s, accepting a wide range of industrial and commercial waste. Over the decades, hazardous substances accumulated, posing a significant environmental and health risk. In response, the site was designated a Superfund site, necessitating a comprehensive remediation strategy to prevent further contamination and ensure public safety. Here we see the condition of the slope after grading, but prior to the installation of the permanent GeoWeb cap. The solution involved capping 51,000 square feet of the landfill, basically all the slopes that were 3 to 1 and steeper, using the GeoWeb soil stabilization system. In this case, we used our 30V12 material, which is our 12 or mid-size cell, 12 inches deep. And this innovative approach ensured a robust and stable cap, effectively containing the hazardous materials and meeting the EPA's requirement of a 12-inch cover. Representatives from Presto Geosystems and the local distributor provided on-site technical and installation support to ensure the success of the project. The GeoWeb sections were pre-assembled at the crest of the slope with tendons and ATRA tendon clips, which were then anchored at the crest of the slope. Sections were connected using the patented ATRA keys. The keys are inserted through adjoining GeoWeb cell walls, turned and locked to provide the most secure connection. And ATRA tendon clips were used to secure the tendons running through the GeoWeb cells. These clips locked with the GeoWeb cell walls with a looped tie-off, ensuring the tendons remained securely attached. The setup was crucial in preventing the slope system from shifting, providing an effective erosion control solution. And the anchored GeoWeb sections were deployed down the slope, ensuring that each section was securely anchored and properly aligned. Here's a highway slope where iron pyrite was exposed during excavation. When exposed to air and moisture, there is a potential for acidic runoff with elevated concentrations of contaminants. Here, the slopes were covered with a geomembrane, and aggregate-filled GeoWeb was placed over the liner as a protective layer. The slopes were up to 1.5 to 1 and up to 200 feet high. While not a landfill design principles were used. Finally, a project from 1997 that does not involve a geomembrane, but rather preventing erosion of the up to 200 foot high, 1.5 to 1 shale slope at a solid waste transfer station in Jefferson County, Alabama. Other solutions that were looked at were riprap, which was deemed too expensive, and building a retaining wall at the bottom of the slope to collect the inevitable erosion, which was deemed to be too much maintenance. Eventually, the solution that was selected included a 4-ounce nonwoven geotextile to provide separation and an in-plane drainage layer, and 3-inch topsoil-filled GeoWeb panels. The system was then hydroseeded and an erosion control blanket was installed. Well, normally hydroseeding and an erosion blanket is an either-or proposition. The idea here was to create a complete system that would eliminate the need for any chance of future maintenance. So here we can see the results 2 years after the installation in 1999, where we have some vegetation growing up on these steep slopes. And 15 years after the install in 2012, we have not only vegetation as well as larger trees beginning to grow. And finally, very impressive performance 25 years after the installation in 2022. In summary, every project is different, but the GeoWeb system has a solution that is right for you. The GeoWeb system can be added to road projects to provide a more stable and longer lasting surface course for unpaved areas, which will reduce maintenance and repairs. For paved surfaces, GeoWeb decreases pressure on the subgrade to reduce differential and long-term settlement, which will extend pavement life. The ability to use low-quality aggregate or even sand can save a significant amount of money. Whether you're looking to stabilize your roadway, protect your embankments, or manage your stormwater runoff, the GeoWeb system has great flexibility of design to meet your project needs. And it is a complete system solution for ease of installation and peace of mind. To reiterate, we offer free project evaluations for any potential project, regardless of size. That process starts with a request for project evaluation form, which can be found on our website, prestogeo.com. Within 3 business days, but usually faster, we will provide a complete design evaluation, including infill recommendations and anchorage requirements. We will work with you to get you the best design for your project. I would also like to introduce a new web-based software, Presto Geo P3, where you can plan projects yourself within this portal. This software offers you a suite of geotechnical calculation tools designed to support engineers, contractors, and project owners in completing value engineering evaluations using GeoWeb geocells on load support applications. It allows you to create and download your own project calculation summaries like shown on this slide. And you can find this software at prestogeop3.com. We deliver quality and over 40 years of expertise, guaranteeing each shipment meets or exceeds our written specifications so you can deliver certainty and build with materials you can trust. Hopefully we covered all the learning objectives to your satisfaction. If you'd like to discuss anything in more detail, you can contact me directly, and my contact info will be coming up here shortly. We've made it fast and easy for you to obtain your PDH certificates. With our webinar dashboard, you can easily view our library of webinars and download PDH certificates for on-demand webinars completed. Your webinar dashboard will keep a record of on-demand webinars along with PDHs earned. Please note that certificates for live webinars are managed separately from the on-demand webinar dashboard. So you won't find your certificate from today in there, but you will receive an email from GoToWebinar within the next 2 hours containing a download link to obtain your PDH certificate. In 2 to 3 days, you will also receive a separate email from Presto Geosystems with more information about accessing the on-demand webinar dashboard and with other helpful resources. If you do not receive either of the previously mentioned emails, please check your spam folders. And here's my contact info if there are questions that come up later. I do want to thank you for attending and remind you that you can send questions to us anytime at info@prestogeo.com or directly to me at the email listed here. Go to prestogeo.com for a wealth of information, and don't forget to view our YouTube videos found by clicking on the YouTube icon in the upper right-hand corner of our webpage. I'll answer questions next, but if you have any that I don't get to, or you think of a question later, you can respond to the follow-up email and we'll be happy to answer your questions and help with project recommendations. So we'll now take a look at any questions that may have been submitted during the presentation. Let's see. Scrolling up to the top, does Geosystems offer a green alternative to slope stabilization for slopes up to 2 to 1, similar to a competitive product like Flexterra? Pretty sure we have covered that during the presentation, so the answer is, of course, yes. Any chance of getting a copy of the slides? Feel free to shoot me an email directly to the email address you see on the screen right now, and I'd be happy to send you a PDF of the slides. Are you ever requested to sign and seal with a professional engineer's seal for the products that we have assisted with? We don't really have engineer stamps in all 50 states, so we typically are not going to do that. But we will do is we will work as closely to the engineer of record as needed to make sure that they are comfortable with what it is we are providing. Another question about getting the slides. So again, just send an email directly to me. I'll create a PDF and email this slide deck to you. So that looks to be all the questions that we have here this morning. So we're gonna cut everybody loose about 15 minutes early. I hope everybody has a good remainder of your day. And again, don't hesitate to reach out with a phone call or email if you do have any further questions.